My channel, myself Parag Jambul. In this video, we will see an important topic in C++ language, that is Standard Template Library. In short, it is called as STL. Now, by name, if we see, so standard means it is standard or it is common among all the users of C++ language. That's why it is a standard. Library, so it is just like API. So library means some predefined classes and functions are provided. That's why it is a library. And there is one more word, template. So whatever the predefined classes and functions are there, they are provided with a generic data type using the concept template. So already we have seen template in C++. So predefined classes, they are provided with the templates with the generic data type, and that's why this is called a standard template library. Now there are various components, but out of that, three are important. One is container, second is algorithms, and third is iterators. There is one more component or one more entity that is called as a container adapter. So afterwards we'll see it. Now, containers, from the name will come to know, containers means what? It contains something. That's why it is called as containers. Now, in our programming language, containers, that means which contains the data. Those who are holding the data, those are called as a container. So, see, STL is basically similar to the collection framework in Java language. And here in C++ we have the STL. Containers which contains the data. Simple example, vector, even array, list, stack, queue, dequeue, all these are the containers. And they are called as containers because they contain the data, they are holding the data. And that's why they are called as a container. How containers are implemented? Containers are implemented by the template classes. So classes with the generic data type. So in this way, containers are implemented. There are 7 basic kinds of containers. Here you can see. So these are the 7 containers. And out of these 7 containers, 3 are the sequence containers and 4 are the associative containers. And these 7 containers are the basic containers. These containers are called as the basic containers. And from these 7 basic containers, 3 containers are derived. Here you can see. So from this 7 basic containers, these 3 containers are derived: stack, queue, and priority queue. Now see. So first we'll see. So these 7 containers that we have seen, they are categorized into 2 parts. One is a sequence containers and another is associative container. Now what do you mean by sequence containers and associative containers? Containers which can be accessed linearly by the indices. For example, 0, 1, 2, 3, 4, just like array that we access. Those are called as sequence containers. So here elements can be accessed one by one in a linear way, and that's why these are called as a sequence container. While in associative containers, these are accessed by the keys. One simple example I will give. For example, students, they have the roll numbers, right? So roll number student. So students can be accessed or they can be called by their roll numbers. So roll number is called as a key and student name, that can be the value. Likewise. So when the data is accessed by the keys, then such kind of containers are called as the associative container. And these containers, data is accessed by the indices, linear indices. Now see, we will go one by one. Vector. So vector is just like array, but one major difference is it is a dynamic array. Now see, array, when we say, so for example, if we define integer a of 6, so 6 is the size of the array. it is fixed one. But vector is a dynamic array, means its size get incremented as per the requirement. Its capacity get incremented as per the requirement. And that's why it is called as a dynamic array. And here that name that is used vector, and it is implemented by the class vector. For all these containers, we have to use the header file, and header file is same. For example, vector class header file is vector, list list. For set, header file is set. So for all the containers, we have to use like. Then a list implements linked list data structure. So in linked list data structure, as we know, data is saved in terms of nodes, and at each node there is a data and also there is a pointer. Then DQ stands for double-ended queue. So see, queue we know. So queue a data structure, at one end we can enter the data, while from the another end we can remove the data. But in DQ, it is a double-ended queue. So it is a queue where you can enter the data, you can insert the data and delete the data from the both the ends, and that is called as a DQ. And so here it is implemented by this DQ class. Then associative container. So already that I have told, data or containers having the data which is accessed by the keys are called as associative containers. Now in associative container, again there are two major types. One is set and another is map. Now see, that previous example that I have given, that is a roll number and students. So when the data is saved like key value pair, so roll number as a key object and student names as a value object. Or other example, for example, capital, state name and capital. So Maharashtra, Mumbai, Karnataka, Bangalore, Kerala, Thiruvananthapuram, something like that. So when we have the keys and objects, values. So key value pair, data is saved in terms of key value pair, that is called as a map. So in map we have pairs, pair of data, key value pairs. While in set only we are saving the key objects. There are some specialities or features of the set, that it implements data is saved as a binary search tree. So internally it implements binary search tree. Then data is sorted. So all the data which is saved in this set is sorted. Then we cannot modify any data. So we can remove it. We can remove one element, then we can modify, and again we can insert. But within a set we cannot modify any value. Within a set we cannot modify value of any particular element. So this is the speciality of set. But see, here we are not using any index. Here there is no index to access the elements. So that is a property of the associative container. Now see, here there is only one key, while in multi-set it has a multiple keys. In the same way, in map we have only one key. In multi-map there are the multiple keys. Now see how objects are created. So see, that I have told, all these are the classes, class names. So objects, we have to define the objects, right? So for example, vector A, set B, and this map C, something like that. But in these containers are implemented as a class templates, and because of that we have to mention in angular bracket data types. So what is the data type of the placeholder that we have to mention? So vector stands for the integer data, set of integer data, something like that. And about the map that I have told, it saves the data in terms of pairs, key value pair. So this is the data type of key and this is the data type of the value. Now see, these are the 7 containers, 7 basic containers, and from these 7 basic containers there are 3 specialized containers. Those are defined, but these are defined from the previously that are told sequence container. These specialized containers are derived from this sequence containers, and construct which is used to define this specialized container is called as a container adapter. See, again I am repeating, construct which is used to define the specialized containers from the sequence containers is called as a container adapter. So by these container adapters we got these three specialized containers. So here you can see stack can be implemented as a vector list DQ. These are the sequence container. Queue can be implemented as a list or DQ. Priority queue can be implemented as vector or DQ. Now see stack. So stack, it is used to implement stack data structure. So stack data structure already we know, it is based on the principle last in first out. Queue, it is used to implement the queue data structure, and it is based on the principle of first in first out. So whatever the element which is inserted first will get removed first. Now see priority queue. So it is just similar to queue, but there is one major difference. So see for insertion it is same. So randomly the element get inserted from the one end, but in while removing the element, so in queue whatever the first element that is entered inserted, that is get removed first. But in priority queue, while removing the elements are getting sorted, and after sorting whatever the element is there at the removing end, that is get removed, and that's why it is called the priority queue. Elements are arranged as per their priority, as per the sorted order. That is not the case with the queue, but this is a special thing about the priority queue. For insertion it is same, but for removing the element, before the removal of elements are getting sorted. So this is called as a priority queue. Now see, this is how we are creating the objects of this specialized container. For example, stack. So here see angular bracket we are mentioning like this. So here we have written stack can be implemented as a vector, list and DQ. So here DQ is mentioned. Now see there should be space here. If you remove this space, so it becomes a special character, special operator in C++ language. So as we know, it is a extraction operator in C++ language. So that's why always there should be one space. So in this way these specialized containers are defined, and they are defined using the construct called as the container adapters. So there are 7 basic containers, and these are the 3 specialized containers which are derived from the basic containers. And also we can define our own containers by using the basic containers. Now see, so this was the discussion about the containers. So in next videos we will see the programs based on the containers. Containers, they have the header file. For example, that I have told vector, so we have to include header file vector. In the same way, for algorithms we have to include header file algorithm. In next video when we will see programs, so there we will see. So for algorithms we have to include header file algorithm. Now what kind of algorithms are there? So these are the predefined algorithms. Already functions are there. These functions are the template function, generic with the generic data type. These functions are for the sorting purpose, searching purpose, copy, merging the data. For this purpose these algorithms are defined, and these are the predefined function. Algorithms are predefined. They are implemented as a function. We don't have to define them, just we have to use them. They are provided by the STL. Now third most important is iterator. Now see, iterators are just like the pointers. Just like pointers are used to access the element, in the same way iterators are also used as a pointer, just like a pointer. But actually they are not pointers. They are used just similar to the pointers. Actually, these are called as smart pointers because see normally pointers they access the element which are in a sequence, right? But these iterators are used to access the elements from the complex data structure. These iterators are implemented as a nested classes. For example, see, a vector will have nested class iterator and it is used to access the elements of vector. A map will have a nested class iterator and that will be used to access the elements of map. Same ways with the set, list and other containers. So these iterators are specialized to access the elements of particular container, and because of that they are defined as a nested classes of these containers. Iterators connect algorithms with the containers. Simple example here you can see. So sort is algorithm. This V, suppose this is a vector object. Now see, so begin is function provided by the vector class and it returns the front iterator pointing to the first element. Then v dot end, so this end function returns the iterator which is pointing next to the last element. So here see, this iterators is connecting this algorithm sort with the container vector. So in this case it is connecting to the vector. So they connect algorithms with the containers. So in next video we will have programs for that, and there we will see how iterators are actually used to access the elements of the containers, and we can access them one by one. Just like it for the pointers, we use the operators star dereferencing pointer or member access operator or dereferencing operator. We can also use it with the iterators. Similar to that, this increment operator, decrement operator, we can use it along with the iterators. Just like pointers, we can use it with the iterators. So these operators are overloaded to use with the iterators.